All right, it's time. Moving forward with JUnit 5 by Marcel Snell. Please do give a warm welcome to Marcel.
Hey. 皆さん、おはようございます。Unlike that previous slide, sorry if I misled you, this talk's actually going to be in English. Sorry. So I'm Marcel, and I'm an Android developer here at Tenten in Tokyo. And I've come here to talk to you today about unit testing, more specifically about JUnit 5. And, well, I think that a framework like JUnit 5 doesn't really need that big of an introduction because everybody knows JUnit, right? I mean, you've got your syntax, you've got your test class, got a method in it, then you annotate it with a test annotation, you do your assertions, you run it, and you verify that your application logic is working as you expect it to. And in fact, JUnit is so well known, and it has been for decades now, that it has matured over the years and now has become by far the most popular library on all of Maven Central and the most pulled in external dependency in all of GitHub. So this is how you'd pull in your JUnit today, right? I mean, we've got version 4.12, which is the version that we all know. And just to put that into context, that was released in December of 2014. And to put that into context, the JDK 8, so Java 8 development kit, that was released in March of 2014. So it has been a few years since the new version 4 release. I think there's a version 13 like in the works, but no idea when that's going to come out. But that's not what we're going to talk about today, because we're going to talk about the successor to this, what we all know and love, hopefully. So a couple of months after this release, in July of 2015, the core maintainers, or like some of the people behind the whole JUnit initiative, they were kind of conceptualizing in their heads what a successor to JUnit 4 might look like. And in July, they turned to crowdfunding of all places. I think they went to Indiegogo and started a crowdfunding campaign looking for funds to dedicate their work on writing the new version, the new concept of JUnit. It was called JUnit Lambda at the time, and I can only imagine that was because like Java 8 was so new at the time, and Lambdas were like everywhere basically, and they were like, hey, we want to kind of cash in on this, and we want to kind of focus on these new kinds of ways that we can write our code. But eventually they kind of realized, hey, maybe just going with the proper JUnit 5 is a better option. So a couple months after, they properly renamed JUnit Lambda to JUnit 5. So JUnit 5 is a complete rewrite. So other than the knowledge that the core maintainers put into this project, no code was reused. And you could ask yourself why that is. Why would you just rewrite it from scratch, especially something that is so kind of established itself and is like very concise, it works perfectly, why would you rewrite it? And there's a couple of reasons for this, and I'm going to go into a bit more detail on both, on two of these to kind of motivate why this step was made. And the first one is what I call use-site coupling. And to explain that, today's tooling that we all use kind of depends on JUnit's internals, and it kind of really makes it hard to actually work on the current state of JUnit 4. Let me explain. So here's this test class from earlier again. All I did was I changed the assertion so that this test method would fail, because like 2 plus 2 obviously is not 5. So when you run this from IntelliJ or Android Studio, you'd get a nice assertion error message that says, hey, I expected this, but it's actually this. And you can click to see the difference, and it's all very nice. So with that in mind, let's now work on JUnit 4. Let's make it better. So here, this is actually the first and only slide I've seen on this conference in Java. Everything else has been in Kotlin so far, which is really cool. And don't worry, I won't bother you too much with this. This is a file from JUnit's source code. It's called comparison failure, and it's basically the error class that kind of encapsulates this. I expected this, but it was actually this. And you can see that this class was probably written a while ago, because these fields kind of with the F prefix, that's not something that we would do. I think that's not even something that we would do like 3 years ago, maybe. I don't know when this was written. So you're, as a rockstar developer in 2018, you would go in and say, hey, I can make this better. So you can go and refactor this, and you've made it now very much cleaner. You can just remove the F prefix, change the constructor, and then this is way better now. So you just change private fields, nothing to worry about. So you compile this local JUnit version that you modified just to verify its behavior. You install it using Maven, whatever. You install it into your local Maven repository. And then you go back to your other project, apply this new snapshot version of your local thing, and you build it again. And what you come to find is that you completely broke the integration with IntelliJ at this point. Well, we all know why that is, probably because the JetBrains folks probably reflectively look into these fields to extract the values out of it to make their UX experience a bit nicer. But it's just one of these things where you go in and you look at it and you say, okay, well, how am I supposed to work with this? And this is just one instance of the JUnit 4 codebase where it's really hard to touch anything without the fear of accidentally breaking everything. Because it's just one dependency, and over the years, people have kind of reached into the internals to provide a nicer experience for people. So this use-side coupling. Another really quick reason is ambiguous evolution, and that is tied to conflicting requirements that kind of reduce the scope of JUnit over the years a bit. So here's an example. If you want to write a parameterized test in JUnit 4, what you would do is you use the parameterized runner, and you annotate your test class with the run with parameterized annotation. And that means you have different, like you can annotate a method and then you can pass different inputs to the method and it's going to execute it multiple times. So now you develop this a bit more and you're like, I kind of want to use Mockito as well to mock my user object, for instance. And then Mockito docs tell you, okay, you can just slap on the Mockito JUnit runner on your test class and then you're in a pickle because there can only be one runner per test class. So you can't just slap another one of these run with annotations on top of it. So the folks at Mockito were nice enough to provide another mechanism. And in fact, in JUnit 4.6, there was a new concept introduced, which is this rule annotation, which is another way to extend test functionality so that it doesn't clash with the runners that we all used to use before that. So this is fine. You can use it like this. But now you've got like two concepts for extending tests, like rules and runners and who gets precedence. Like, it's a bit confusing. You can use it, of course, but we can do better. Enter JUnit 5. So JUnit 5, as opposed to just being one single dependency, is comprised of three different components. And when we talk about JUnit 5, we talk about the sum of these three components. So I'm going to introduce all three of them real quickly. First is the platform. And on the top here, these are two actual library like jar modules that are named like this, and they compose the JUnit platform. So what is the platform then? It's basically the access points for plugin and build tools developers to hook into running tests on the JVM. So the JUnit platform is really kind of an agnostic layer to run tests. It's not even tied to like the new APIs that we're going to spend the rest of this talk talking about. It's just a new way to write tests and execute and launch them on the JVM. There's an interface called Test Engine in here, and that's kind of the central, at the core of how this works. It's just an interface, very abstract, and kind of, it doesn't really know about the implementation details. And then you can imagine frameworks like Spec or Spock or whatever other test library you know, they could implement their own test engine and then hook into this kind of JUnit platform approach, and then the developers behind it could have their tests run on the JUnit platform. And then there's the launcher API to kick off the test runs, but we're mostly developers here, not really build tools or like IDE developers, so that's kind of the IDE side of things. So next is Jupyter. Again, two separate artifacts, API and engine. We're going to look at that a bit more closely now. Jupyter is the new programming model for JUnit tests. So you might hear somebody say, hey, I want to write a JUnit 5 test. And when they say that, they really mean they want to write a JUnit Jupyter test, usually. So here is where the new annotations are bundled in. So the new test annotation, the new other features that we're going to talk about in a bit. And also a new extension point API for a unified extension of test cases. And then Jupyter Test Engine is an implementation of that test engine interface I just talked about, and that basically hooks it in to the JUnit platform. And the third component, that's called Vintage. And it's just this one dependency, it's called Vintage Engine. And that's basically, you can just think of it as the backwards compatibility layer of JUnit 5. So like with Kotlin, you don't have to commit yourself wholly to just upgrade your entire test code base completely, you can just leave your old tests for a while and then write new tests in JUnit 5 maybe, and then migrate everything over gradually. So Vintage is basically just another test engine implementation that hooks into like JUnit 4.12, and then you can execute JUnit 3 and 4 tests with that. Here's a diagram that that tries to explain how this component model works together. And thank you to Nikolai Parlok, whom I lifted this very nice representation of how you can display these components together, which I lifted it from him. So at the top, you got your tests, right? And above that, that would be your application. On the bottom, you got Android Studio or Gradle or whatever you use to launch your tests. So now, you write your tests with the JUnit API dependency, basically. So that's where the annotations are. You just put that in. You write it with that. Then, at runtime, the Jupyter engine, the test engine, discovers and runs the tests you've written using that API. Next, of course, the Jupyter engine is an implementation of something that is in the platform engine dependency. So platform engine, the blue guy here, that's just where the test engine interface lies. So that is implemented by Jupyter. And then from the other side, you got a dependency called launcher, which finds and executes these test engine implementations using the Java service loader mechanism, actually. But it drives and orchestrates kind of the execution. And then the launcher is basically the only hook-in point or the only usage point for Android Studio and Gradle. So they use it from that side. You write it through the other side. It's very clear-cut and separate from each other. Now, but on the same token, like JUnit 4 fits in this model as kind of a separate way. So your tests written with that library are discovered by the Vintage engine, and then that again hooks into the launcher using the common interface. And on the same token, like every other framework you can conceive, that would have the same kind of way of being detected automatically. So let's look at what Jupyter gives us. And let's start off by just the basic stuff of, okay, what's the new names for the things we already know? Because why upgrade if, of course, you can do everything with JUnit Jupyter as you could before, because otherwise, why bother upgrading? So first, this table displays just basically the find and replace things that you can do to just use the new annotations. So the test annotation is still called test. It's in a different package, though. It's a bit confusing at first, but you'll get used to it. Then the ignore annotation from JUnit 4, that's now called disabled. Does the exact same thing, just disables test execution for this method. And then categories, which were used to group together sets of tests, that's now called tag, and it doesn't use a marker interface class anymore, but instead like a string, kind of like Dagger with its named provides. Then, of course, still, there's the life cycle. So you know how the test method, there's like a specific setup and tear down phase for each method, and the test class itself, of course, that's still there. It's just on a different name. So just, I won't go through all of these like in detail now. It's just a different name for the same concepts. Now, what's really interesting, and probably why you are all here, is the new stuff that we can do, like the things that are kind of like, yeah, the top sellers. From kind of neat to actually really useful. Let's start with display name. Display name is a way to kind of more nicely express or like make our test reports a bit more bearable, and also our IDE reports. So check out this method. It's okay. We're using a camel case, but it's still a bit hard to read. If you execute that in the IDE, like it's a really long name. You can read it. It could be better though. So what you can do is you slap the display name annotation on top of that method. You provide a kind of better name for it. And then when you run it, you get the nice English name and descriptor for it. Now, the groovy folks who are using Spock are saying, like, I could have done this like 2 years ago. Well, you're not wrong. Now it's properly in JUnit, and everybody else can also join in. And then display name also works on the class level. So you can also annotate your test class if you feel like it could be expressed a bit more concisely. And then that, of course, has its representation changed as well. Next up, we got nested. Nested is a nice way to, if you're into the BDD style approach to writing tests, to kind of group together kind of child and parent classes so that they kind of share the same life cycle in a way. So assume we have like a calculator object and we want to test that. So you have a class named calculator tests, and we again use the display name annotation, and we call it the given portion of the test declaration. So given a calculator. Then in there, you'd have your variable, the calculator itself, and then before each test method is run, you want to get a new one. Just basic things. And then you put an inner class in that class that is annotated with nested, and that kind of represents the when portion. So you have multiple ones of these. For instance, this is the class that encapsulates all the test cases related to the plus operation on this calculator class. And you, again, name that using the when portion of the test description, and you say when using plus operator, and then in there you're gonna go and write your test methods, and they kind of comprise the then portion of the test description. So you can be sure that this test method on the bottom here, the 1 and 2 and 3 method, that is kind of hooked into the life cycle of the parent class because it's the nested one. And then if you execute that, you get a nice tree in IntelliJ that says like given this, when this, then that. So that would be the way to kind of facilitate BDD style tests in JUnit Jupyter. Next up is Test Factory, and this is a really interesting one. Alternatively to using the test annotation on a method, you can also use the Test Factory annotation on it. And if you do that, you're expected to have a return type of the method that is either dynamic test or a collection of these dynamic test objects. Basically, what this allows you to do is in your test method, generate new test cases. So like at runtime programmatically, something that wasn't possible before. So there's this API. It's again called dynamic test, kind of redundant, but it's actually very concise in that way. It's a factory method that you pass a string into, which is again the name of the test, and then just a lambda body that kind of describes what you want the test to do. So in this case, we'd have a list of 2 of these dynamic tests that are returned here. And then if you execute that, then you get a nice row in the IDE for each of those invocations. So to summarize, it's tests generated at runtime. However, the dynamic test objects you create inside that method, they don't really partake in that life cycle, because the test factory method, the outside one, that gets called with like before each and then after each. But each of those dynamic test ones inside, they don't get that. And in general, I would prefer parameterized test. I personally have not found a valid use case for test factory methods. Probably some framework integrations will greatly benefit from this, but as a general rule, I would prefer parameterized test. Speaking of which, let's go to parameterized test. Because again, a very powerful mechanism, which we could do before, but it's now on steroids, basically. So again, as an alternative, use the @parameterized test annotation for your method, and then also specify a source. And the source can be many things. We're going to look at a table next, but in this case, I've used the CSV source annotation, and that's basically a way for you to specify comma-separated values, as many as you like, in that annotation, and then the method that it's annotated with, that gets then called for each of those values in the annotation. So in this case, we can expect 3 invocations of this method with different parameters. What's interesting here is that I've used a combination of string and int, and the annotation value, that's just a string. So there's a nice kind of type inference for most primitives and also some other things. I think it can also type infer dates. I'm not sure on that, but I think it can. You could also write your own, of course. But it knows that the number, the 5, 3, 7 parameters, that's an int, and it can cast it automatically. You don't have to just use stringified values in your method. So this is nice. In the IDE, of course, every invocation gets its own row. And there's different possibilities for these source annotations. Due to time constraints, I'm not going to go into every single one in detail, but you can kind of make out from just the name of them what they do. And you can also implement your own providers for these parameterized tests. Really, really powerful. Lastly, another feature I want to just briefly mention because it's so complex, I could do a whole talk just on its own on this. which I actually might do, is extend with and the new extension model for JUnit Jupyter. So it's the unified API that I mentioned before for test extension, and it's the replacement for both run with and rule. So it's just one now. It's called extend with. Because we're in Java 8 land, that annotation is repeatable. So your test method or class, you can have 1 or 2 or 25 of these extend with annotations on top of it, and they don't interfere with each other. So you can just, it's just one way to hook in. And how it hooks in is there's a common interface, I think it's called extension point, and then there's more special ones. And then just by implementing some or all of these, you define what your extension is interested in. So some use cases would be, if you go back to the Mockito example, you could implement an extension that is able to resolve a parameter of a test method that is annotated with mock. So the extension, all it could do is just check for this mock and then provide it. So it's a really powerful mechanism to hook into the life cycle of methods, parameter resolving, all different kinds of things. It's just one very powerful point. And again, deserving of its own talk. Yeah. So where's Android in all of this, right? I mean, I'm wearing a shirt, got the droid in the name. Where's Android at? So the JUnit core team, they provide a Gradle plugin. So it integrates nice with our favorite build system. But that only works for pure Java projects. I think it applies some Gradle plugin that is incompatible with the Android versions. And then it says, hey, you can't have, I think, Java library maybe, and COM Android application at the same time. Something like that. So it didn't work. So when I experimented around, eventually what was initially a PR on the JUnit 5 project, eventually I just moved it to its own project. And under these coordinates on GitHub, you can find that project. And it's called Android JUnit 5. Very creative, I know, but it gets the point across. And what it gives you is unit test integration for Android projects with JUnit 5 and Jupyter and all that good stuff. So this is how you'd pull it in. Nothing too fancy, just know the coordinates. Pull that in, apply the plugin, and then in your dependencies block, make sure to add the dependencies on this. Now this is just an easy setup way. It's kind of bundled dependencies, so you get multiple ones applied automatically when you do this. And this is basically out of a hassle I had where Android Studio used to be built with a different milestone release of JUnit 5, and because the APIs were changing so much with each new release, everything broke all the time. And then Android Studio would always fall back to this older version, and then there was a method that didn't exist in a later milestone, and then people kept complaining, and I was like, okay, for now, this is what you do to pull in your unit tests. Now, I'm excited to announce that for the whole instrumentation test side of things, I've recently experimented around with it, and for the first time, like since a couple of days or weeks, I don't know, since the start of this year, basically, there's experimental instrumentation test support for this as well for Android. And it's basically the successor to what we now use with activity test rule for our Espresso tests, for instance. Now, it is API 26 and above, and that is because JUnit 5 is completely built on top of Java 8. Because why, if you rewrite it anyways, why even bother with the backwards compatibility stuff? And that would technically mean API 24, but some of the reflective APIs used in JUnit 5, they didn't come to Android until 7.1. So it is 26 and up. It's a very high MinSDK version, so for that, it's probably going to take a while longer before we can all leverage it, unless you're on MinSDK 26, which is pretty admirable. I envy you guys, but it's probably not going to be most of us. So this is how you'd pull that in. It's disabled by default just because of the high requirement, but if you want, you can enable it using this this configuration closure here at the top in your test options, and then add the dependencies as necessary to your Android test implementation configuration. So what does it give you? Here's an Espresso test with JUnit 4. Probably most of you are familiar with this. Got your runner, got your rule, got your test method, and then in the method you use the rule to launch the activity, and then you do your Espresso things on view with ID, check, matches, whatever. And then you finish it again. So let's convert that to JUnit 5. So it's pretty much the same thing, but it's just using the JUnit 5 concepts behind the scenes now. This is like my current conception of what this could actually look like once the Android team actually gets around to doing it properly. So at the top, you got your annotation activity test, and then in parentheses, the class of the activity under test. And this is a test extension which has the common configuration options that you use to use the activity test rule for. So you can say, hey, don't launch this activity automatically, or here's the target package. So it's basically a one-to-one copy of what the activity test rule could do. You just specify it on the annotation now. And then your test method that can receive a new parameter of type tested again. And then there's generics that kind of specify the class again. And that is what the rule used to be like for the use side, from the use perspective, I suppose. So on this tested object, there's the methods that we used to use for like launching and getting the activity result and finishing. So that's now there. So the extension registers itself and says, hey, I can resolve if somebody wants to get an activity. I know how to do this. And then it's passed into the method automatically, and then you do your espresso things as you would before. So to summarize, the future is really bright for testing. There's a lot of exciting things, and it has been quite a ride from the first milestone release of JUnit 5, and then griefing over every breaking change and every new milestone release, but still keeping up with them over time. I feel like it's kind of part of me at this point. But still, having said that, it's going to take some more time before we'll all write our espresso tests with this, because, again, API 26 is a pretty high cost of entry at this point. But still, if you want to dabble with it in an experimental branch, like for unit tests, I don't see any problem. You can just do it today, do it right now. But for instrumentation tests, again, yeah, it's going to take a while. But still, the tools that we have today make it possible already to become an early adopter of this great new exciting adventure. Again, these are the coordinates. This is the link where you can find the repo at. If you want to work with me on some cool tech with vending machines, 1010 is always hiring. So check this page. Maybe you'll find something interesting. Reach out. That would be great. And that's all for me. Thank you so much.
Thank you, Marcel.